This conference will now be recorded.
Okay, so now for removing particular some portion, I need a material. Okay, so what I'm going to do, I'm going to select on pad. Okay, so now it is asking for pad, but for doing some adding material, I need a closer profile. I haven't drawn any profile. Have you seen it? Okay, so I haven't drawn profile. So what I'm going to do, so in the sketch, see profile or surface, if we already have a profile, we can select in here by using mouse. Okay, we don't have any profile. What I'm going to do, in the same no selection beside this one, there is a sketch symbol. Okay, icon is there. So I'm clicking on the icon and select a plane where we need to apply sketch. Okay, so I'm going to select a basic rectangle. Exit workbench. See what I have done previously. Whenever I want to do some part, first initially I will go for sketch, and after completion of sketch, I'm exiting from the workbench of sketch, and in the pad workbench, I mean the part workbench, I'm going to click on the pad. After that, I'm going to select the sketch whichever I need to pad. Okay, so this is the basic procedure. In case if you don't have any sketch, okay, then also you can directly click on pad, and in the pad tool you can go for drawing your sketch. Okay, so I have drawn some sketch. Click on preview and click on OK. So I just now added a particular pad for this particular cardboard. Okay, sketch 1 and pad 1. Okay, is this clear now? Now what I'm going to do, I'm going to apply a pocket. So same here, with either I can go first, I can go and draw sketch. Okay, after that I can pocket that one, or else in the pocket itself I can create. See, I selected a pocket. I don't have any sketch to pocket. So what I'm going to do, I'm going to select the sketch toolbar, and in this one, either we can select a face or a plane. Okay, so I will suggest you to select a plane itself. Okay, why I will tell you later. Okay, now I'm selecting the face. Just for explanation purpose, I haven't created any plane, so I just directly selected the face. Okay, so now directly I'm going to draw profile what I need to pocket. So this is the profile, exit workbench, or face. I'm going to short decrease the size. Okay, so exit workbench. Now I can give depth preview. Okay, see, I have pocketed it, right? So in the same way, we can either follow the basic steps, or else we can follow this second method also. So now I'm going to draw a sketch. See, in the sketch toolbar, we have two types of sketch. First one, normal sketch. Second one is position sketch. Now I'm going to, by selecting here after select, see, I have directly selected a normal sketch. Okay, now I just selected normal sketch. Whenever I'm going to select on the particular face where I'm going to draw, what will happen? It automatically rotates itself. Okay, see, I don't want to be oriented like this. Okay, I don't want to be vertical like this or horizontal like this. So how I'm going to change the orientation of this particular sketch? So exit workbench. Okay, so go for position sketch. Okay, in here it will ask for reference. This is the reference face. See, by defaultly the system generating horizontal downwards, vertical in this horizontal direction. Okay, so So what I need to do, I need to change the orientation, axis orientation based on my requirement. So how I'm going to change? So I need to change the vertical into outside and horizontal into horizontal direction. Okay. First, in the base, see this is the sketch positioning toolbar. So in here we have some reverse hedge, reverse swap, these three options. Based based on these three options, we can change the orientation. Okay. First, what I am going to do, for example, reverse hedge. Okay, I have reversed it. So now horizontal in vertical direction, vertical in horizontal direction. So I can directly swap this position now. Okay, swap its orientation location. Now what happened? Horizontal in horizontal, vertical in vertical. Okay, click on OK. So now it's formed as per my convenience. Okay, so like this, we can use the position for orientation of this sketch.
మేడం ఇంకొకసారి చెప్పండి.
Yeah, surely I will explain repeatedly. No need to worry. Okay, so before that, I am going to draw some basic sketch. Exit workbench. Okay, so I'm going to apply grafted filleted. Okay, just decrease the radius. So I'm going to decrease the depth into 15 and apply the second limit as this plane or as this face. Okay, so now give the angle of 5. There is 5. I'm going to increase it to 15. 1 5. Sorry. Okay, so now it is asking from the whether we are going to give the drafting from the first limit or second limit. Okay, from the first limit, and we can change the radius. Okay, lateral radius, first limit radius, second limit radius. I'm going to change the lateral radius to some 3, and first limit radius to 8. Okay, so click on preview. See, click on OK. So are you able to see? I will change its edges. Okay. Now see what happened. A pocket with drafted filtered pocket has formed. Okay. So this is the lateral edges which we have given 3. Okay. This is the radius of 3 mm and this is the radius of 8 mm. So you can check them directly from by clicking on the position. Okay. This is the 3 mm and this position is called this. Fillet edge is 8 mm. Okay. And this one is defaultly 5 mm. We haven't changed this 5 mm. Okay, like this we can change it, draft it with fillet edge. Okay, someone is asking that what is the meaning of convert points into construction element. Convert points into construction element. Just a minute. Where have you seen that particular option, ma? Okay, so once again we have this multi-pocket. So multi-pocket I will explain later. So multi-pocket and as well as the multi-pad. So these two are similar, but I will explain you in the last. But in pad option there is no conversion to construction. Okay. Okay. So padding, when you are padding, you got an error, right? So that is nothing but there are some lines. Okay, so instead of your enclosed profile, there are additional a point maybe there. Okay, so you need to find out the exact location of the point, whether you can delete that particular point, or else you need to change that point into a construction. Okay, see, for example, I'm going to take a position sketch. Okay, so position sketch I have selected. Now this is the reference plane. Okay, so what I need to do, I need to change its position. Okay, so swap its location. This vertical is downwards. I'm going to reverse vertical. Click on OK. Okay, now I'm entered to position sketch. For example, I'm drawing a rectangle here, but by mistake I have created a point also. Exit workbench. Okay, so click on file. So what will happen? The selected sketch contains point definition as standard geometric element. You must convert the point into construction elements. Okay, so what I need to do, I need to go for a sketch. Okay, so in the sketch we can see sketch solving process. It is under constraint. We haven't given it any time constraints. So in this one, go for geometry. Okay, in the geometry you will see whatever the point, whatever the line, so everything will come to geometry. So as per the profile, it is a closed one. It contains four curves. Okay, four lines. Okay, so when it comes to a point, it is isolated. Okay, what I need to do, whether I can convert this particular point into a construction. Here is the bottom is a point set in construction mode. Okay, so I haven't deleted it. It is still there, but I changed it to a construction, and I'm going to close this one, exit the workbench. Now, so there won't be any problem. Once you converted a line or a point into a construction, so it won't comes to 3D. Okay, only a continuous lines will come updated into 3D. Okay, whatever the elements are in constraints, they won't update it to 3D. Okay, so now we can change that one too. So understand now? Click on OK. Okay, a block is formed like this. So next one, shaft operation. For example, I need to draw another object. So I'm going to select position sketch, select the any plane. So I have selected another plane. So in here also, I need to swap its location and reverse the vertical. Click on OK. Okay. Now what I'm going to do, I'm going to draw some profile. Okay. You know shaft operation. Shaft is nothing but a cylindrical. Okay. We can draw the cylinder basically by using circle, or else, for example, I need to draw some rim. Okay. Okay. For example, you have seen two-wheelers, right? In the two-wheelers, what there will be a rim. Okay. I need to draw a particular rim. So I'm going to select sketch. So I'm going to draw a rim shape. Just I'm drawing it in randomly. So don't take it as it's not the exact shape. Just a random, it is just a random shape. Okay. I'm going to draw an axis line. So this is the axis line, exit workbench. Okay. So I have drawn an axis line, but what happened? It won't appear in here. so you cannot use that one. Okay, so we can directly use the planes also. See, for example, this is the profile. I'm going to select the shaft operation. See, directly by with the reference of horizontal axis, x-axis, so directly shaft is completed. For example, for my reference, I need to see a portion of cut section. Okay, so I need to see the portion of cut section. So I can change the angle into 270. Okay, so out of 360, I have given 270. Click on preview. See, it is in this direction. I can change its direction also, reverse direction. Now, preview. See, here. Or else we can change it. We can divide the 360 into two types. I mean, two angles. First angle, second angle. So, either we can give total angle in the first angle itself and give the second angle as 0, or else we can divide these two into, okay, so from the basic sketch, one direction is first limit, another opposite direction is second limit. Okay, so this is the limit one. From this limit one up to 270 I have rotated. Okay, or else I can change this one. So from this limit one, this is our sketch. This is the basic sketch. Okay, so this is limit 2. So whatever the angle I have given, that comes to limit 1. So up to where I need to give. So from limit 1, first angle, let's give it a 180. Okay, so up to 180, only half of this session will be there. Preview, see, up to here. And I'm going to give second angle. Okay, in the second angle, I'm going to give some 90. Okay, from here it will change. So it is in same direction. So give it a reverse direction. So 990. See, so this is the second angle. So it comes to in this direction. Preview. Okay. So like this we can apply the shaft operation. See, so whatever the shape, okay, whatever the shape you need in a circular profile, I mean circular shape, so you can apply shaft operation. Okay.
మేడం
What is it, Manish?
మేడం ఇప్పుడు మీరు డ్రాఫ్ట్ డెఫినేషన్ వెళ్ళి ఆ డైలాగ్ బాక్స్ లో ప్రొఫైల్ సర్ఫేస్ వాటిలో వెళ్ళి సెలెక్ట్ చేసుకున్నారు. అదే డైరెక్ట్ గా 2D స్కెచ్ తీసుకోవచ్చు కదా.
Yeah, you can take that one. Either way, see, there are so many shortcuts and so many methods. Okay, I am telling you a path. Okay, so I am not only telling a single path. I am telling you the possible ways you can enter.
ఓకే
Okay,
ఓకే ఓకే
so you can choose as per your convenience.
ఓకే మేడం.
Okay, so this is the shaft operation. Next one, so in this like this only, for example, in a circular method we have added some material by using shaft operation, but like the same way I need to remove the material from this one. For example, I need to make a hole throughout this entire disk. Okay, how I'm going to do? Same way, see, select this face. Okay, so I'm going to select this face and give a position sketch. So change its okay, it is all right. Click on OK. So now just give the circle what you need to remove from this particular shaft. I'm going to draw this circle in here. Okay, exit workbench. So remember, for shaft operation as well as the groove operation, you need to give an axis. Okay, so for this particular one, I'm going to give the horizontal axis as reference. Okay, so if we don't have any axis, we can give a line reference. Okay, I will explain line also, no need to worry. So select the groove operation. So it is asking the sketch profile. So sketch profile is already taken 7, and it will ask the axis. Axis is nothing but this horizontal axis. Okay, so now observe, it is taking reverse angle. See, okay, so from this one it is taking a reverse direction. This is the direction of limit 1 and this is the direction of limit 2. What I need to do, I need to change its direction. Okay, I have changed it to the, and now it is limit 1 and it up to here limit 2. Okay, so I'm going to zero the second limit, and in the first limit itself I'm going total 270. Okay, click on okay. See, completely entire throughout the shaft we got the hole. Okay, so like this we are applying shaft as well as the groove operation. Okay, next one is hole. Hole is nothing but we have different types of holes. Like see, I'm going to select a hole. So where I need to exactly form a hole. For example, I'm going to select. I need to form a hole on this particular face. Okay, I have selected the face. Now it will directly enter to the, see, this is the hole definition box. I already told you. So there are different types of holes. See, these are all the types. So in the normal, a hole is of throughout hole is there, blind hole is there, or else if you have several stacks, so you can give up to next, up to last, and up to plane. So you have already given in the pad and the pocket out now. So like this, you can give the same options in here. Okay, when it comes to type, so there are simple hole, tapered hole, counter bore, counter sunk, or else you can give counter drilled. Okay, these are all the basic types of holes. So I am going to give some taper hole. Taper hole is nothing but it will form it. See, this is the preview of holes. So this is a basic simple hole. This taper hole. So it will apply some angle. Okay, tapering angle. Next one is counter bore. Counter bore is nothing but if you are if you have observed some electronic instruments like remotes or something like that. So there will be taper hole. Whatever the screw we are giving, it will completely fix into the object. Okay. So like this, counter bore as well as the countersunk is also there. Okay. It is mainly for screws. Next one, counter drill. Okay. Like this. So these are all the basic types. We can give the parameters of those particular screws. Okay, so and what I'm going to do, I want counter bore. For counter bore, we need to give the diameter of the head as well as the shaft. Okay, so I want, so in here, so 15 is large, so I'm going to decreasing it to some 8 diameter. Okay, so next one, okay, this is the diameter and this is the depth. Okay, I need to decrease this one in order to decrease the head. So I'm going to give diameter 5. When it comes to parameter of counter bore, so I'm going it 8 here. Okay. So previously it has shown some error now. It is nothing but the diameter of this small shaft should be equal or less than the header. Okay. So now I have given the head as 8 and the shaft as 5 mm. Okay. Now there won't be any problem. So next one is depth. Okay. Head depth is 5 mm and the hole depth is 10 mm. Okay. So now click on preview. And before giving a preview, so see, I don't know the position, exact position of the particular hole. Okay. So how I'm going to give position sketch is there now. So click on position sketch. Okay. So now we can exactly position the hole. See, this white star-like shape is in, so that is the whole center point. So now by using constraints, I am giving it dimension. So from the edge to this point, some value 10. Okay, 10. Okay. Next one, from this point to this vertical edge. Now I am giving the same value here, 10. Okay. So now the circle, whole of the center point is constrained its position. So exit workbench, click on preview. Okay. See, I'm going to zoom it. I will rotate it for your understanding. See, so counterbore is formed with head of 8 diameter and depth 5, and the inner circle is of 5 diameter, depth 10 mm. Okay. Okay. Everything is clear now. Like this, we form a hole. Next one is sweep operation. Okay. It is also called a rib. So in this one, we need two sketches. One is basic profile and second one is a curve. For example, in pad operation, what we can do, we can directly uh, draw a profile and we add the thickness in perpendicular to the profile. Okay, when it comes to a shaft operation, what we do, we are going to add some material or thickness in a circular way. Okay, so when it comes to this particular rib operation, we can add in any direction we require. Okay, for example, I'm going to form an example for this one. So I have selected this particular face and giving position sketch. Okay, now what I'm going to do, I'm going to give a particular position. I mean, like in which direction and which curve I need a thickness. Okay, so I'm going to give a spline curve starting from here. So like this, we can give any direction, but what we need to do, so we must make sure that the curves are not intersecting with one another. Okay, that is the first and foremost rule for applying rib. Okay, so now I have given some irregular shape like this. Enter. Okay, so this is the irregular shape I have given. What I am going to do, I am going to exit from this particular sketch. See, so sketch 10 is what I have drawn. Exit from the sketch. Okay, so I need to create a plane perpendicular to this particular curve. So how I'm going to do? So in the bottom of the reference plane, so reference element, there is plane. Select the plane, and in this plane options also, so normal to curve is there. So what I need to do? I need to select a curve. Okay. So it will ask the point. So in which point in entire curve we can form at any point the plane. Okay. We can form a plane at any point. Okay. So I need to form the plane at this particular point. See, a plane in the green color has formed now. So we can move the plane to any direction or any distance along with the curve. Okay, so I just need it here. So click on preview. Okay, it is formed. Now I'm selecting the plane here. So I'm going to click on position sketch. Click on OK. So now I'm going to draw some profile in here. For example, I can draw a circle or a rectangle, whatever. Okay, I'm drawing a basic circle in here. Exit workbench. Okay, so now I'm going to apply this rib operation. Okay, selecting the rib. So in the first one, it asks for profile. Profile is already taken. This sketch 11 is the profile. Next one is center curve. What is the center curve? This is a sketch 10. So sketch 10 is profile, sorry, center curve for the particular rib operation. Okay, see, we haven't even given the any operation like I haven't even given, just I selected profile and I have given this center curve. Okay, for example, see, I'm going to click on review. See, entire path, center path along the curve we have given center curve. So along the path we will get the thickness. Okay, so like this we are going to apply sweep, wave option. Yeah, sure, I will explain once again. For example, in previous when I am designing a car, I have given the rib operation. Okay, for example, see, assume it as my, yes, same, different for different softwares, different terminology will be used. For example, in AutoCAD, you will say that extrude. Okay, when it comes to when it comes to CATIA, the same tool is called as a pad. The same way, in some softwares it is called a sweep, and when it comes to this software, it is called reverberation. Okay. See, once again, I am going to explain that particular reverberation. See, I need a middle plane here, so I'm going to select a plane. So in here we have another option. See, so either we can create mm, through two lines or through point lines or through plane curve. Just we can select some, or else we can simply go for offset from plane. So I'm going to give offset in reverse direction. Give it as 10. Now in this particular plane, see, that plane is in middle now. So I'm going to draw some position sketch. See, I need to swap this location. Click on OK. Now I'm going to give this spline like a handle. I have drawn a, there won't be any. Okay. Just a minute more. Okay, just it's a cylinder I'm going to draw. Preview, click on OK. So I have just drawn a cylinder. So for this cylinder, I need to create a handle. So what I am going to do, I'm going to select this particular plane. Go for position sketch. See, even though we draw in the plane, it won't attach it to this particular edge. So I need to create another plane. I'm going to select here. So normal to curve. Create a point for giving the point for the plane. So I'm giving the plane here. Okay. So at this point, I need to create a plane. So this is the curve. Click on OK. And now give the point. This is the point. Okay. Now I'm going to select this particular plane. Go for position sketch. Click on OK. Okay. I need to draw line. So from here to here. Okay. Exit workbench. Next one, we need to create another plane. See, change it to normal to plane. Okay, this is a plane. I need to create a normal to plane. (90° angle). It is asking for rotation angle. So we need to give an axis. We don't have a we haven't drawn any line for giving the axis, right? Let's try once again. Rotation axis is of this one, and the 90 vertical direction. Click on preview. No, it is asking for. Okay. So I will give a line also. So in the bottom, I can create a point. Click on OK. So I'm going to join these 2 points. Or else we can directly form a plane by using normal to curve. Okay. So I directly select this curve. and the endpoint as here. Okay. So now we can give the profile. Okay. Go for normal sketch. So now we are going to give a small circle. Degree workbench. So directly go for rib operation. In this rib operation, previously I haven't explained this natural fiber, merge fiber, and this merge ribbons or thick profile. Okay. So for this only I have started this lengthy process. So center curve it is asking. This is the center curve. Okay. Without giving any of these options, preview. I'm going to click on preview. Click on OK. I will zoom it for your visibility. See, I'm going to rotate them. See, the edges are not connected to the particular cylindrical shaft. Okay, not only in the bottom, in the top also. These are not connected. So for this, we need to create them attached. Okay, go for rib. So in here, merge ribbons is there. Okay, so click on preview. So whatever the ends are there, so it will automatically merge with the cylinder. Okay, so see it is attached enough. So now I'm going to create thick profile. Okay, for example, I need to create this is a solid. Okay, it doesn't have any hollow. Okay, for example, I need to create some hollow. So I need to click on thick profile. Now it is asking about thickness 1 mm. Okay, either I can increase or else I can decrease. So I'm going to increase it. So first thickness as see 6 mm review. Okay, or else I'm going to divide them into thickness 1, thickness 2. So one is inside, one is outside. See, we got the outside thickness additional of 3 mm. Next one in the bottom is also there are two options. One is natural fiber, second one is mergence. Okay, natural fiber is nothing but it will automatically take the thickness to. Okay, it is nothing but equal whatever the thickness we have given in the first fall segment. So it will automatically take the same thickness to outer profile also. Okay, it is natural fiber is symmetric similar to the mirror. We have given mirror extension in pad na. So whatever the thickness we have given in the first direction, the same thickness will be mirrored in the second direction. The same way, when it comes to natural fiber, same whatever the thickness we have given in the first thickness, the same applies to second thickness. Okay. So next mergence, the ends will be merged with the cylinder. Preview, click on OK. Okay. See, the ends are completely merged with the cylinder. Okay, unlike the previous one. So like this, we are going to create a slot operation. Sorry, rib operation. When it comes to slot operation, so previously we have created a non-uniform directional of the segment rib operation in there. In this one, if you want to form this particular thing into a hollow, ఇప్పుడు simple we are going to form this particular one into a hollow one, or else we need to form some design in the particular shaft. Okay, what I am going to do, I am going to select this particular plane, select the position sketch. Okay, it is directly selected the normal sketch. Okay, no need to worry. So what I am going to do, just zoom this particular position. Okay, see, I need to make some designs in here, like removing. So I'm going to remove in here. Okay, so a portion will be removed, or else I can increase it, removing portion. Okay, up to here I need to remove along the rib operation. Exit workbench. See, when we created a rib operation, we have created a path. Okay, so the same, when we are going to remove the material in this particular solid, we need to give some path also, the same path. So instead of drawing the path, what I am going to do, the sketch here is in hidden now. I am going to unhide this particular sketch. So if not that one particular one. So in the rib there is a sketch. Right click the one, hide or show. Next one. Okay. It is not sure. Okay. This rib belongs to this one mark. So in here we need to unhide this one. Okay. Now it is formed. So these are all belongs to different sketches. Okay. So I'm going to select the slot operation. So what is the profile I need to remove? So this is the profile I need to remove. Okay. So next center curve. This is the center curve. Preview. Click on OK. See, along the path, it will remove. For adding in a path, we are going for rib operation. For removing in a path, we are going for slot operation. Okay. Next one is a solid command. In the solid command, we can use different sketches. Okay. Up to now, what you have observed, so what in the pad, in the shot, or else in the rib operation also. So whatever the profile you have drawn in the beginning, okay, if you drawn in the profile as a cylinder, the end also, another end also will be a same cylinder, okay, or else if you drawn a rectangle, the another end also a rectangle. So instead of that one, so I'm going to combine different sketches. For example, I'm going to draw a sketch in particular this plane, vertical plane. Go for position sketch. Okay, vertical and horizontal in the position. Click on OK. So in here, what I'm going to do, I'm going to draw half circle. Okay, cut the half section. Or else change the circle into something else. Profile. Okay, so I'm going to change it to spline curve from here starting like this I have given. Okay, so before exiting from this particular sketch, we need to check whether it is a closed profile or not. Okay, so for that one, we are going for sketch analysis. In the geometry, it is a closed one. Okay, next one, exit the sketch. Now what we have done? So we have completed a sketch. So I'm going to draw another sketch in perpendicular to this particular sketch. So this one, click on OK. See, perpendicular to the previous sketch, I'm going to give another. For example, take a rectangle like this, exit button. Rectangle is a closed sketch, no need to check that one. Okay, so now observe, sketch 1 is a spline curved closed object and the second one is a rectangle. I'm going to combine these two. Okay, so in combining these two along by using solid combine. Okay, so here select the first component. This is my first component and it is asking for second component. So this rectangle is my second component. Okay, click on preview. See, intersection of both two sketches, we formed a solid combine. Okay, like this. Next one, in the solid combine, we have another option called stiffness. Okay, for example, in this bottom, I'm going to give some planes. Okay, or else I'm going to remove some portion. Pocket. This plane. I haven't got any sketch, so I'm going to select the plane. Exit workbench. Click on OK. So give the reverse direction. So this is the direction up to last. I don't know exact length, so I am giving up to last preview. Okay. See, okay. We have given sketch in reverse direction, huh? So we need to change its position to downwards. Exit workbench. So no, it is not also. Okay. So no need to worry. So in this one, we are going to apply stiffness. Okay. So I will try once again. Okay. So this is the exact position what I required. Okay, for the convenience, I have changed the sketch location and exited the workbench. Whatever the changes I have applied in the sketch, it will automatically, okay, update it to 3D. So now I'm going to create a plane. So this is a plane I need to create in, increase the distance to some 60. Okay, so now I have created a plane. In this plane, so what I'm going to do, I'm going to just draw a line. Click on OK. So I'm going to draw a line from here to here. Exit workbench. Okay. So I need to give some support. Okay, for this particular L join. So I need to give some support here. So go for stiffener. Okay. So up to what the thickness I have applied. Okay, only 1 mm is there. Okay, so I need to increase this particular thickness. Okay, so remember, whatever the thickness you are giving, it will be from thickness 1 only. Okay, so entire completely will be given. 6 mm is the total thickness. Next one is asking, it is taking the natural fiber. Okay, whatever the line we have given, So the thickness will be taken along the line. Next one, if we want to give in reverse direction, we can give the reverse direction. But we don't have any material in the upside or opposite direction. Okay, only in this opposite direction only we have some material. Okay, so this the horizontal face and as well as the vertical face. In the reverse direction, we don't have top face and this particular front face. Okay, that's right. Error will appear. Okay, so I have given the thickness of the 6 mm and click on preview. Okay, a solid stiffener has formed. Click on OK. Okay, like this we form stiffness. So if you don't know, if you want to check exact thickness, we have given 6 mm now. So you can check the thickness also. In this one, measure items is there. So you can give either you can select the face for area or else you can give lines. Okay, this line length is 25.25 mm. So I need to measure the length between these two. So from here to here. Okay, see exactly what is it? 6 mm. Okay, exactly 6 mm. So like this we can measure. So I will explain those measuring elements in later classes. Okay, so like this we form a stiffener. When it comes to last two options in the sketch-based features, these are nothing but multi-section solid as well as the remove multi-section solid. Okay, in the next class I will explain these both. Okay, so let's see what are the doubts you have. Okay, Manaki, we have gone through complete 6 days class up to today's class. Okay, so how you feel regarding my teaching? Okay, after listening to 6 classes, you might have some ideas, right? So I'm going to share a feedback form. Okay, so you guys can upload any feedback. Like if you guys are not able to understand whatever I'm saying, or you guys are need to be speed up our process, or else we can slow down like this, whatever. Okay, see, we can only combine up to two planes, I mean two profiles in the solid combine. If we have three profiles, we cannot combine them. Okay, three profiles is nothing but we need to combine in 3 axes. So it is not possible. Okay, only in two profiles which are not perpendicular to one another, we can combine them. So someone, Rajesh is asking about, please explain once again. Which one you need, ma?
వెబ్ చెప్పా కదా మ్యామ్ జగ్గకి
Yes, yes, yes.
అదొకసారి అంటే ఎక్స్టెండ్ చేశా కదా మ్యామ్ ప్లేన్ నుంచి సర్ఫేస్ కి ఎక్స్టెండ్ చేశా కదా అదొకసారి చెప్పా
Oh, sure, sure. Okay, so when we have a cylindrical surface, like a cup as an example, ma. Okay, you have a teacup, but you need to give a handle. Okay, you cannot exactly meet the edges of the cup to cup face. Okay, so in that case, what we are going to do? So in the rib option, we have options like merge ribbons. Okay, so directly we can select the merge ribbon so that the ends of the rib will automatically adjust to the next surface. The next surface. If the surface is uh, somewhat very far from the rib only, we will get some we cannot get. So I will show you once again. For example, I am going to draw Go for position sketch. Give a sketch in this plane. Click on OK. So now I'm going to draw a cylinder here. Okay, this is my profile. Now I'm going to give some thickness for this particular one. So 100 I have given. So I need to give a handle for this one. Okay. So what I'm going to do, I'm going to select this particular. For applying a rib option, we need a two profiles. One is a closed profile which I need to follow through the curve and a center curve. Okay. So two profiles we needed. So first I'm going to draw a center curve by selecting this particular plane. Go over position sketch. Click on OK. So now I need to create a handle in this direction. I'm going to select the spline. Directly I'm giving the spline position. Okay. From here to like I'm going to draw like this. Okay. So exit workbench. Vijay, give them the feedback form. Okay. I have given a center curve. Now what I'm going to do, I need to create a plane perpendicular to this particular curve. So go for plane. So now select the curve and select the endpoint where you are going to create it. So this is the endpoint. Click on OK. Okay. So in this particular plane, I'm going to give a sketch. Okay. Click on OK. Now I'm going to give a circle. Okay. Exit workbench. So I have given a profile. Now what I'm going to do, I'm going to apply rib operation. Okay. As I have selected a rib operation and profile also, this circle is selected, and when it comes to center curve, I'm going to select this spline curve. Okay. So I'm going to select the preview. I will zoom it for your understanding. See, the edge is not completely, not even touching this cylindrical surface. Okay, not only in the top, in the bottom also the same. I will show you. See, in here. Oh. See, in here, it is not even touching it. So not only here, but also in the bottom also. Okay, so how I'm going to attach these two ends? So here, mergence is there, na? So I'm going to select the mergence. Okay, preview. Okay, see. Okay, so completely the ends are connected to this particular cylindrical object, right? See, I'm going to rotate this and observe. This completely attached now.
Yes, ma'am.
Okay, like this we are going to apply the rib. Okay, all of you give the feedback form, so it will automatically update it to our higher authorities. Okay, so read all the instructions. I have this.
Hello, ma'am.
Yeah, tell me, Rajesh.
మేడం స్మాల్ అంటే ఒక సిలిండర్ చుట్టూ గ్రూవ్ లా ఫామ్ అవ్వాలంటే ఏం చేయాలి మేడం? అంటే స్పెరల్ లాగా.
Okay. For example, you are going to create a spiral. It takes too much of complete another step one. So you can remove any material by do in a directly cylindrical manner. Okay, but not in the particular spiral manner. If you must have need to create a spiral manner, you have to create a surface. In the surface, you need to project your profile. Okay, this is a lengthy process, but I will explain you after this particular class. Before that, we need to learn all the tools.
Okay, thank you.
Okay, so up to now, if you have any doubts, you can ask me now. So today I have explained some tools from this shaft, groove, hole, and rib option, and slot one, and stiffener, solid combine. Okay, these are all the basic tools. So if you have no doubt, so I will continue with my class. Okay. For example, so I told the to explain this multi-section solid and removing of multi-section solid and remaining two options in here in the next class. Okay. So I'm going to start the dress-up features.
మేడం
Yes.
ఒకసారి
Explain.
రివాల్వ్ కట్ చేస్తారా?
Revolve cut. Okay. For example, I'm going to draw a shaft and I'm going to remove material from the shaft by using groove operation. Okay, so for this particular shaft, okay, no need to give this one. I'm going to draw another one. Go for position sketch, select this particular plane. Click on OK. So now what I'm going to do, I'm going to give a profile. Okay, so for example, I don't have any axis system. So basically, previously I have given axis system also. I mean, directly I have selected the axis as the center axis. So now what I am going to do, okay, so this is the shape, in an irregular shape I have created. Exit the workbench. Okay, so I have just drawn a irregular shape, so I need to create an axis system. Okay, so I need to create an axis for this particular object to be shafted. Okay, just either I can select this edge as its shaft, or else I have to create another shaft. So just go for another sketch in the same plane. Click on OK. Okay, now go for shaft. So first profile, this one is my profile. When it comes to axis, this one is my axis. Okay, so axis will be in another sketch, and profile will be in one sketch. Both two sketches are there. Okay, profile is of in sketch 8. When it comes to axis, it is of sketch 9. Okay, so I'm creating 360 angle preview. Click on OK. So up to now, all of you understand. So for creating particular shaft operation, is there any doubt? So you have to remember, if you don't have a center axis and general center axis, you have to create your own center axis. Okay, so profile, whatever the profile will be in one sketch, and after exiting from the sketch, you need to create your own axis for the shaft operation. Not only for the shaft operation, you have to create your own axis for the groove operation also. For example, in here I need to create another shape. Okay, so what I'm going to do, just I need to create a, yes, this is the plane. Select the position sketch, click on OK. So I need to remove some material. Okay, so in here I need to remove. Exit workbench. Okay, here I have drawn a circle. Okay, so I already have this axis system, so I can reuse this same axis system. Go for grow operation. In this grow operation, profile we are going to select this particular circle. Okay, so when it comes to axis, we are going to reuse the old axis. Preview, click on OK. See, we have removed it now, like this. We have removed the shape. Not only circle, whatever the object, it should be an enclosed one. Either a rectangle or a irregular shape, whatever it may be. Okay, so like this we are going to shorten row operation. Yeah,
Okay,
got
madam.
it? Okay. So next we are going to dress up features. So these are all the dress up features. Okay, for filleting or chamfering or drafting. So there are so many applications in the dress up features. For example, see, for this particular object, it has a sharp edge. Okay, I don't want any sharp edge. I want to make it as a round one. So what I'm going to do? So if I'm going to change it in our sketch, we can change. So after going to the sketch, in the shaft operation, we can change the particular edge and use the corner option. Okay, it is a lengthy process now. So instead of going to sketch, we can apply the modification in the part only. Okay, so for example, in the dress up features, first one is of, see, fillets. There are 5 types of fillets. First one is normal edge fillet. So this is the edge I need to create a fillet. So select the edge and give the radius. Click on preview. Click on OK. Now completely the edge is completely filleted with radius of 5 mm. Okay, it is edge. Next one.
Ready?
Okay, so next one is called variable edge fillet. Okay, na? Variable radius fillet. When it comes to edge fillet, whatever the radius we have given completely, so for entire edge will the same radius will be there. When it comes to variable radius fillet, we can vary the fillet radius. For example, I'm going to apply here. Okay, so for this one, I'm going to take variable radius fillet. Okay, so for a particular edge, there will be 2 endpoints. See, so 2 elements are there. Those are nothing but endpoints of the line edge. Okay, so now I'm going to add some points. Okay, I need to vary. For example, so see how I'm going to add. See, for example, I'm going to add another point in the middle of the line. So how I'm going to see, in the points there are 2 elements are there already. Okay, right click on this particular 2 elements and there are several options for creating a point or midpoint. So there are several options. So what I'm going to do, so I'm going to create a midpoint for this particular one. So automatically it will create. For example, I don't want any midpoint. Okay, so I can create anywhere along this edge. I can create anywhere. So I already said, so I just need a midpoint. So I created a midpoint. Now what? So I'm going to click on preview. Okay, so and for all the 3 points, so only radius 5 is there. Now I'm going to change its radius. So click on the R5. You can change the value. For example, I'm going to decrease the 5 into 3. Click on OK. And next one, I'm going to change the 5 into 8. Click on OK. And for the third one, I can increase or decrease, whatever. So I'm going to give it a 15. So 15 may be too large. So I'm going to give 10 mm. Click on OK. Okay. So after giving different radius, click on preview. See, so the radius variation will be shown here. See, from the beginning we have given 3 mm, and in the middle we have given 8 mm, and in the end we have given 10 mm. See, why midpoint is required? Just I have given additional point. Okay, midpoint is not necessary mark. Just I just want to add another radius. Previously only 2 radius are there, so I want to add another radius for a particular one. So I thought of giving it in a middle. So I created a midpoint. Okay.
మేడం ఇంకొక
What is it, Manish?
ఇంకొకసారి చెప్పండి మేడం, అర్థం కాలేదు ఒకసారి.
Okay, sure. See, I'm going to explain once again. For example, I will undo this previous one. Okay, now we have a sharp edge here. Okay, so I'm going to apply a variable radius fillet. Okay, name itself indicates the radius will be varied. Okay, previously what we have done, previously whatever the radius we have given to edge. Okay, for example, see, for the same edge I'm going to apply a normal edge fillet. So only the 5 radius will be completely from the starting to ending. Only uniformly a filleted curve will be generated with the given radius. Okay, when it comes to this various radius fillet, okay, so in this one we can vary the radius. Previously what I have done, created 3 points. 2 points are belongs to its starting and end point, and I have created another point in the middle. Or else I can create more than 3. So I'm going to create a point. So along this curve, so select somewhere where you need. So I'm going to select here. So here is one point. Click on OK. Next, again I need to create another point. So here, so just I'm adding inputs. So I'm increasing the inputs. Okay, so 2 points I have added. Click on OK. So total 4 elements are there. Okay, instead of this 4 I'm going to add midpoint also. So midpoint is not necessary, just I am adding them. Okay, so I have added total 3 elements, and the 2 previous are already there. Total combined 5 elements are there. Okay, so for all the 5 points we have the same fillet radius. Only 5 is there defaultly. So I can change the fillet radius from here. Okay, so I'm going to change the first one to 3 mm. So next one to 5, and next one to 10. After that I'm going to change them into again 3. Okay, so now preview, click on OK. See, so from the beginning 3, 5, 10, 5, 3, like this, increasing and decreasing. We can change based on our requirement. Okay, we can change the radius of the fillet edge based on our requirement at any point. Okay, so like this we are applying the variable radius. Next one is Codal fillet radius. Okay, for this one we need to give Codal length. For example, I am going to apply for this one. Okay, so in here it is a given 3 mm. I am going to increase it. See, it is of 6 mm. I am going to 10. Only 10. Click on OK. Okay, so it contains 2 points and it will be forming 2 edges. Click on preview. Okay, just like cutting mark. See, here, like this, a Codal fillet will be formed. Next one is a face-to-face fillet. Okay, face-to-face fillet can be created for here we have formed a L shape now, so we can apply face-to-face in here. Okay, for this face and for this face we can create a fillet instead of using edge. This is the first face and this is my second face. Okay, this is my first face, this is my second face. I have selected 2 faces. I am going to give a radius 5 mm. Okay, preview, click on OK. See, the fillet is formed here now. I will rotate for you. See, the fillet is formed in here. So like this we can apply face to face fillet. Next one is right tangent fillet. Right tangent fillet is like there is no short edge for this one. Okay, see, okay, I'm going to create another rectangular box for applying right angle. See, here I'm going to create a rectangle. Okay, so like this I have created a rectangle and it has a thickness of 10 mm. Click on OK. Okay, a rectangular box shape is created. So by using tritangent, basically what, for example, we need to convert the particular edges into a half circle curve. So what we need to do, we need to again remove the edges. Okay, instead of removing the edges, we have option called tritangent. So directly select the tritangent. So it will ask for faces to be fillet. Okay, so I'm going to select, rotate this one. So this is a face I need to fillet. Zoom that. Okay, if you are unable to select any object, you have to zoom that particular. Okay, so then you are able to select the face or edges. So this is face. So these two are the faces I need to fillet. Okay, remember these two are the opposite faces I need to fillet. When it comes to face to be removed, so which face I need to remove? For example, I need to remove the top face. Okay, so I need to remove this top face. Preview, click on OK. So like this, right tangent fillet will be formed. See, okay, like this, completely half circle fillet will be formed. Okay, attendance link. I think all of you have given your feedback form now. So now Sir will post your attendance link. You can give the attendance. Okay, ma'am. So up to now, if you have any doubts, you can ask me.
Hello, ma'am.
What is it, Nivas?
Ma'am, if you are drawing in Sketch and you are converting into 3D by clicking on the exiting workbench,
Yes.
then I'm getting a dialog box, ma'am. That it is not in constraint, so you can't do that.
Okay. So in the beginning classes, I have explained about, see, in the toolbox, go for options. Okay. There is an update one. So in there, whether if you only have an ISO constraint, fully constrained object only, it will allow to convert the 2D into 3D. Okay. We need to uncheck that one. So tomorrow is Sunday. No need to worry. I'm not going to take any class. Okay. See, in the sketcher, we will in the last one update is there. So generate update error when the sketcher is under constraint. Okay. When the checkbox is on, it will every time even a single point is left out without giving any dimensions or position. It will show the dialog box. Okay. So for your content, you can uncheck this one. Okay. Okay. Blue I can explain once again. So attendance link has been posted. You can give attendance. And one more thing, ma. Here I haven't explained the. I only previous classes in I only explained the sketcher. So in the sketcher we have. Okay, it is not moving from this. Okay, see, sketcher is completed. Now what we are doing? We are creating a 3D. Okay, so go for go for 2D layout, 3D design. So these are visual 3D view creation and visualization geometry. Okay. Wait a minute. It is now visible. In the mechanical design, we see part design. This is the part. See, go for part infrastructure. Okay, in the infrastructure, go for part infrastructure. Previously, every time we have opened, only a planes will be there. Okay, so 3 planes will be there. So instead of 3 planes, for example, I don't want 3 planes to be up here. So in the display, okay, in the part document, you can directly every time when you open a new part, you can directly create a access system in here. Okay, go for options in the infrastructure, part infrastructure, and open it in a part document. In the part document, you can directly checkbox. You can create an access system every time when you open a new part. Okay, so I have created a access system, and also there are several different types of options are there. So geometric set, order geometric set, or a 3D workshop board like this are there. So some of you have asked about when we are opening a new pod, it is not showing any dialog box. Okay, if you are unchecking here, there won't be any dialog box asking for you. Okay, like rename the name part, like that it won't ask. So you have to check this box. Then only you will get a dialog box whenever you are opening a new part. Okay, next one here, hybrid design. So hybrid design will enable to design inside the part bodies and bodies. Okay, so when creating, we can create a body, or else we can create in a geometric set. So I default is checked in body. Okay, so what is the body? I will explain in the later classes when it comes to Boolean operation. I will clearly explain them in there. Okay, next. Okay, colors are normally, you all know color indications. Next one, madam, how to zoom in or zoom out this part? Operation P. Okay, ma. So, for example, for some of you, this tree will be very small, small letters. So, for that one, you need to see, click on this particular tree, and directly you can zoom out or else zoom in by using normal how we are going to apply zoom in or zoom in, zoom out, zoom in, zoom out for sketch. How we are going to do? Directly press on your hold on to your middle button and right click on your cursor. Just right click and delete it, and you can move forward to zoom in and move backward to zoom out. Okay, so like that you can change the size of this particular tree, option 3. Okay, so this is the, and when it comes to display, so external references are constraints. What, for example, whatever the constraints we have applied in the part, it won't be appeared in the display part. Okay, we don't want to, because it will only create a complete destruction. Okay, only when the part is there we can see and create and modify the part. So it contains a constraint. Every time we click on the part, the constraint will be clumsy enough. So like this. Next, here axis system display size. Okay, this, for example, we have a small size of axis system. We can increase the size. Okay, 33, like this. Now I'm going to close this one. Click on OK. See, I have applied all the changes what I required. So I'm going to close this particular workbench and I'm going to reopen new one. Start, mechanical design, go for path. See, now my dialog box is there. Click on OK. Here, axis system, defaultly it is created. Okay, planes are there, but they are hidden. Okay, like this, either you, I have already taught you how to create your own axis system. Okay, so instead of planes, so if you don't want every time to create your own axis system, you can change your settings in the option and it will defaultly appear in your part. Okay, okay ma, so let's stop up to here.